Hey everyone, Morgan coming back at you. We're going to be finishing off the lecture outline for Unit 3 on reactions today. And we're on page number 7. It's the Honors Chem outline. Okay. We're going to be talking about precipitation reactions and solutions. So some of this is some review for us. That's okay. What's it mean to say that something is soluble? It means that it can dissolve. Usually in water, that's what we're going to be talking about, but there are some other solvents out there, but we'll stick to water for this class. So something that is soluble will dissolve in water, okay? Now, is that the same thing as dissociating? The answer is no. When something dissociates, it dissolves first, and then it breaks up into ions. So something like NaCl solid being added to water will break up into Na plus and Cl minus. Okay? So now you have more particles than when you started with. And this happens because the sodium chloride is bonded ionically. Water, which is a polar solvent, is going to yank and tug on these ions until they're pulled apart. Okay? So, why does this happen? Why do substances dissolve? Well, polarity of the bonds has a lot to do with it. And just the random molecular motion of the water molecules, just pushing them all around. Okay? Now, let's not forget the words solute and solvent. Okay? Solute is being dissolved, whereas the solvent is doing the dissolving. Now, our kind of ghetto definition: solute's what we have less of, solvent is what we have more of. Get a little more technical. Solute is the substance that is being dissolved, and solvent is the medium that it's being dissolved in. Okay? All right, so the term precipitate, which we have used previously. A precipitate is a solid that forms in a reaction. That means it is an insoluble compound, one that water is not capable of dissociating. So, let's draw a beaker here. Here's our beaker. It's filled with water. So I've got lots of water. But what I also have in here would be sodium ions and chloride ions. Technically, I don't have NaCl because they have separated. I have Na plus and I have Cl minus. Now, I can boil this, have all the water evaporate, and I'll get the NaCl back. Okay, it hasn't changed into a new substance. Okay? Now, if I have a beaker of NaCl and AgNO3, start off right here. Of course, I have the water. I have Na plus, I have Cl minus, I have Ag plus, I have NO3 minus floating around. Now it turns out that the Ag plus and the Cl minus are not soluble. So what I get here at the bottom is a pile of AgCl. minus sign there. But the Na plus and the NO3 minus are still floating around and are still separate from each other. Now, if I boil this water off, I am not going to get NaCl and AgNO3 back. What I will get is AgCl and NaNO3. Chemical change has occurred here that is making something else. Okay. Now, hopping on to page number 8, we're going to talk about what this looks like in a double replacement reaction. Now, here's a table of solubility rules for inorganic compounds. Now, I'm not going to make a big deal about you going home and memorizing this, because even if I did, you probably wouldn't right now. You'd probably just look for the chart when taking a test, okay? So, you'll learn these as we go. It'll just become second nature, all right? So, what we have to do is think about a possible double replacement reaction, okay? NaCl, aqueous, and AgNO3, aqueous. If they switch partners, give me AgCl and NaNO3, okay? Now, the states of matter. I go up here and I look at my solubility chart. Chlorides, so I find something here. Chlorides are generally soluble compounds, except those of Ag plus, Hg22 plus, Pb2. Hey, that's Ag plus, that's what we're looking for. Since it is not soluble, we're going to put an S for solid. It forms a precipitate. Now nitrates, I look up here and I see the rule that nitrates, acetates, chlorates, and perchlorates are always soluble, which means that's going to be an aqueous. So that's my molecular equation. That's what happens to the molecules. What about the ions? It turns out I don't actually have NaCl aqueous. What I have is Na plus aqueous plus Cl minus aqueous plus Ag plus aqueous plus NO3 minus aqueous to give me AgCl solid. I write that one together because it's a precipitate. And Na plus aqueous and NO3 minus aqueous. Okay. Now, just like in algebra, I see that I've got Na plus on both sides of that equation. I'll cancel it. I've got nitrates on both sides of that equation, so I'll cancel that. And what does that leave me with? Ag plus aqueous plus Cl minus aqueous gives me AgCl solid, and that is what we call a net ionic equation. Now, I know that some people are likely to get concerned because here the Cl minus plus Ag plus, I put it the other way here. Think about this. 1 plus 2 equals 3. But 2 plus 1 also equals 3, doesn't it? It doesn't really matter the order I put them up in front here. They're still going to give me the same answer. Okay, let's look at a slightly different example now. Let's do a partner exchange here and get BaSO4 and NaCl. I'm going to need 2 of those because I got 2 there, 2 there. It's balanced. Chlorides I already learned were pretty much soluble, except there are 3 exceptions, and sodium's not one of them, so that's aqueous. BaSO4, sulfates are generally soluble, except those of, and barium's in that list. So that means barium sulfate is my solid. So that means Ba2 plus aqueous, and 2 Cl minus aqueous, and 2 Na plus aqueous, and a sulfate, SO42 minus aqueous, will give me BaSO4 solid and 2 Na plus aqueous and 2 Cl minus aqueous. Okay? And the Cl minus cancels the Cl minus, and the 2Na plus cancels the 2Na plus, and I'm left with Ba2 plus aqueous and SO4 2 minus aqueous to give me BaSO4 solid. And that's my net ionic equation. Sorry, my S's are a little messy looking there. Okay, we're going to be spending several days on this. We're going to do several different types of activities revolving around this. Okay, so dive into your homework, give it a try. Might be a little frustrating at first. Don't worry, you will get good at this given time. Okay, this is Morgan signing off.